Here we have an incompletely specified state table that we're supposed to reduce. So since it's incompletely specified, you can assume whatever you want. And you will get a different answer if you make different assumptions. That doesn't mean one is right and one is wrong. So just because you don't get the same answer as someone else doesn't mean that yours is wrong. You just have to say what it is that you're assuming. So let's assume here that the outputs are all 0. So if you assume something else, that's fine. You just might get a different final answer. So I'm going to assume the outputs are 0. And our first partition, P1, will equal all of the states. Yeah, I'm trying out this new color that has, like, it changes just for fun. Okay, now we're going to partition it based on the outputs. So any state that has the same output, we're going to put it in the same partition. So our different outputs, let's see, we have 1, 0. So 1, 0, 1, 0. So we'll put those together. And then we also have 0, 0, 0, 0, and 0, 0. So we'll put those together. And then we have left over 1, 1. So we start with 3 partitions. So P2 will be, let's see, the highlighted ones here, BG. And then the ones I marked with red, which are C, E, and F. And then the one that I circled, which is D. So now we want to look at the 0 followers, or 0 successors. So B, its 0 successor is D. So B, its 0 successor is D. So let's draw on a little arrow. And G, its 0 successor is also D. Okay, so the 0 successors are the same. D, of course, is going to be all by itself. C, its 0 successor can be whatever. So we'll just leave that one alone. E, its 0 successor is F. And F, its 0 successor is E. And so we could just say C's 0 successor is E. It doesn't matter. So these all have the same 0 successor. So C, E, F. Because they're in the same partition. Now we'll look at the 1 successors. D is already all by itself, can't do anything. B, its 1 successor is G. And G, its 1 successor can be anything. So it could be G or B, but it might as well leave it in the same partition. So we'll have BG together. And then C, its 1 successor is, let me get a different color. C, its 1 successor is G, over here. E, its 1 successor is B, that's in the same partition. And F, its 1 successor is also B. So their 1 successors are all in the same partition. So that doesn't change. So we're done now, because we checked the 0 successors and there was no change. We checked the 1 successors, there's no change. There's no sense in going back and doing the 0 successors again, because that's also not going to change. So we now have it reduced, and so we can just choose an element for each one. So let's choose B here, and let's choose C here, and D here. So present state, next state, x equals 0, x equals 1, and output x equals 0, x equals 1. So our present state, B, C, and D. And then for x equals 0, the next state we see for B is D, and that is one of the ones that we chose. And the next state for B for 1 is G. G is in the same partition as B, so we'll call that B. C, its next state for 0, that was incompletely specified. Let's check E. E, its next state was F. Okay, so that's what we've got here. So in this partition right here, so our next state here will be C. And C, when P is 1, the next state is G. That's the BG partition, so that's B. And for D, the next state is C for 0 equals 1, and D for P equals, so C for P equals 0, sorry, I think I said that wrong. C for P equals 0, and D for P equals 1. The output for B was 1, 0. For C was 0, 0. And for D was 1, 1. So there's your reduced state table.